Hello all. Welcome to Visuara AI Lab presents Machine Learning in Production lecture series. If you're a beginner in machine learning, which platform would be the first you would explore? The platform that you would explore will be Kaggle. Always, if you just look back, if you are advanced in ML, so just remember what was your first Kaggle project. So your first Kaggle project might be cat versus dog classification or a Titanic one. These are a few projects that every ML practitioner has gone through once in his life at the beginning stage. But have you ever wondered that is that cat versus dog classification task enough with that given accuracy? As you can see here in a notebook, cat versus dog, where they have achieved 98% of accuracy, where they have achieved 98% of accuracy. So they have taken almost 25,000 images and then they have split it into train and validation belonging to two classes. Then they have defined VGG16 model. Then they have trained a model, fit the model and evaluated. And after doing that, when they plot results, the results were amazing. You can see the loss value is low and it was decreasing per epoch, and the accuracy was quite high. And this is what we expect when we run a machine learning model. If you see, the training data is having 99.5% accuracy, whereas the loss of the model of training data is 0.01. But you might say, what about the test data or validation data? We need to have good accuracy on that because while training, it has already seen that images. So definitely it will have a good accuracy for that. But the validation data accuracy of the model is also good, that is 98.6. And loss of the model for validation data is 0.03, which is amazing. But my question is, do we have just 25,000 images on entire internet for cat versus dog classification? No, we have billion of images and it's very difficult to scrap it from internet. So what if there is some confusing image and that is given to this model and it can't predict, then what is the use of this 98 or 99% accuracy? Let's take an example. You can see there was clean example with having a cat and then 0.01x noise is added here. And when noise was added, it predicted this is mosquito net. Imagine if you are having this example and if you gave your cat's image and it predicts mosquito net. Is that correct? No. Then your model needs to improve. So what we understand from here is that real life data is different than our Kaggle model. So sure, you might have achieved 100% accuracy on cat versus dog classification task, but that doesn't guarantee that your model will accurately classify any image outside the dataset. What if we are building a vehicle detection system for government surveillance project? When we see a vehicle detection system, the image that comes to our mind is something like this, where it is predicting which is the model and which is the company of the vehicle. But my question is that if I want to do a vehicle detection system, I can detect vehicle in some other ways compared to this image. I can classify or detect the vehicles based on number of vehicles. I can classify the vehicles on the base of this code. That is, for Maharashtra we have MH. For like different districts we have different code like MH30, MH12, MH26. So I can classify like this as well. But my again question that might come to me is like, what I want to do in this project, what are the requirements of the client? So running a Kaggle notebook or Google Colab notebook won't be enough. So I need to think beyond the model. I need to speak with stakeholders. I need to involve business developers or domain experts. I need to think about scalability, deployment, long-term maintenance, Imagine you have a autonomous driving car and you have design and it is in a testing phase, but you didn't thought of its scalability or you didn't thought of long term for that one, and there is noise added in the some images, and when your algorithm is not trained enough to detect noise, that time it can create disastrous outcome. This is stop sign where your autonomous driving car must stop. Imagine you sitting in the car and the stop sign comes, you think, oh, car will stop, but the noise was added. And then it classifies at its max speed 100. And then it goes at a speed of 100. And you can't imagine what will happen next. So these things are need to take care of. So we always need to spoke with stakeholders. We need to involve business developers, and we need to think about scalability, deployment, and long-term maintenance. This is where machine learning engineering meets real-world complexity, and machine learning production comes into picture. So when this all questions come into picture, that time you think you are working on a real life project. It's not limited to your Kaggle or Google Colab. So now machine learning makes a real life scenario, and your entire way of looking at any ML project gets changed. So I would like to give an example. In my case, I was working on this Udemy paper where we were trying to detect AI generated text and we were trying to detect a human generated text, and we used line for explainability that why is it doing so. I was doing the paper well, and after some time when I noticed that I'm getting a good accuracy result, I was quite happy, and I was just working with different models, and I was doing some research gap and objective, then data set generation, then data processing, and then when I came for the modeling, then I tried naive based logistic regression, random forest, etc. But a question comes to my mind when I was doing this was, why am I doing this? Is it just that I want to make model? Just accuracy matters for me? No. I was thinking, what is my thought process behind this? So in the increasing era of AI being used as tool everywhere, I thought that this is necessary to differentiate that which is written by human and which is written by AI. For example, in a test given by student, imagine if student has written entire 500 words essay by himself and it is classified as AI. This should not happen. So I got that this was a thought process behind this paper, and this is how we are going to move forward. So when I get a reason for this, I was like, okay, this is where my model will be useful in the real world. So this is how the questions are to be answered when we deal with real life scenarios. Imagine you are a software developer. So if you are having any question related to the business idea, so it will be related to your code. So you will definitely think like what type of code, what type of algorithm I am using. Imagine if you are a data scientist. So what will be your question, that why is model drifting? Then if you are a model user, then you can say, can I trust its prediction? If I am a business stakeholder, I definitely think of profit. So how much does the model bring? If I'm a product manager, I'll think of limitations, that what are the model limitations? And if I'm a data engineer, I'll say, does it get the right data? This all needs to take care of, and this is how the technical skills and communication skill goes hand in hand in machine learning and production. Your technical knowledge is just not enough to excel in the field. You always need to have a communication skill, which is often overlooked. Now let's read more about this. Working in ML is tough. It involves mastering many tools, juggling data engineering and advanced analytics, and collaborating with experts across team to solve problem and explain the results. It's tough, it's fun, and it's challenging. So you might say that what is my motivation to do this? First of all, we are in the world of AI and everyone needs to have little knowledge of it. And nowadays people are mastering it through a lot of resources available, thanks to social media and thanks to this all open source community through which we can learn without any barrier. So if you want to advance in ML, you need to have this knowledge of ML in production. And secondly, the salary stats. The median annual compensation for data scientists in US is $120K, which is very good. And if it is paid well job, that time we should definitely try to study it if you are interested in machine learning. And if you want to perceive your career in machine learning or AI domain, having a knowledge of MLE in production will definitely help you. Now, let's move to other part. Let's go with the technical details first. Why ML engineering? The aim of ML engineering is not to iterate through the list of skills just mentioned that and require data scientists master each of them. That is a very basic question that might have come to your mind when you have gone through this content till now. That if I need to have technical skill, communication skill, if I need to think of this aspect, then it's very impossible for me to master this all. You need not to master it. I repeat, you need not to master it because it's very tough to master all this, but you should have just enough knowledge of few of the aspects, which is necessity for this. So what I mean by just enough is if you are a software development, if you are into software development, then you should write clean modular code and basic unit test. So if you want to see, like you can see here, you can have a good code where you are properly defining classes. So this is how you maintain a clean code so that if it goes into production, a tester can understand it clearly. Then data engineering, build, schedule ETL jobs for feature, extract it, load it. Visualization. For a business stakeholder who don't have technical knowledge, it becomes very difficult for them to understand what the project looks like and how is it going. So you should have a different kind of visualization to explain them that what your model is doing at backend without giving them the technical knowledge, but they should be aware of that where they are investing is a good deal. Then for the project management, which is very, very crucial, you need to define, you need to scope, and you need to steer the ML project. If you have all the idea, but if it goes beyond your deadline, so no business stakeholder will try to again meet you for this criteria of the project. So you need to plan it very clearly. You need to have the timelines. You need to decide the scope. Like you need to make calendar for that. These elements need to complete by this day. I need to meet this team. I need to get the feedback from the business stakeholder. This all you should think. So this is how you should plan this journey, and then you get just enough rule for this MLE, and you need not to master this all. Now let's look at the major elements of the ML project. First is planning. Assume you are a data scientist and you have to work on vehicle detection system for the government. Then you have some questions for government that how should I classify vehicles, like based on number of wheels or based on the number plate, and what should be the toll for that specific vehicle if I want to cut the price according to the vehicle type. These are all questions you need to ask with government stakeholder because he's or she is the one who is bringing this project on table for you. So you need to ask them this question so that you can work accordingly. Then the next is scoping and the research. Here you will have to know what kind of database you are receiving, what kind of algorithms you can use. If you are getting some number plate into Excel form, then can you process that? Which algorithms will work? Do you have to use YOLO V8 or do you have to do OCR? Something technical questions, technical research has to be done here based on what database you get from the government. And if you have some questions regarding that as well, that you need specific data set or specific data type, that needs to be conveyed as well. Next will be experimentation. After developing a model, you need to experiment it at some small level. You can ask government that can we try this on some local system or can we try it on some test data set. This will come under the experimentation part, like what can we test and who can test it. Next is development. Once you see the experimentation is going well and there is no error into experimentation or your model is performing well on the local setup, then you can develop it. For that, you'll need to write maintainable, testable, and extensible code because you'll have to test it and this codes will need to be get updated every time. So for that, this should be extensible code. If some new features has to be added in future and that is demanded by the government, then your same code should have that ability that it can be extended as well. Else, it will be problematic. Next is deployment. Deployment will be needed for validate performance and to see whether your model works in real life scenario or not. Because this Kaggle model or Google Colab won't be enough. This has to be integrated into CCTV cameras where it works. Let's have a look at this image. You see this is a vehicle detection system. Then it goes to traffic video monitoring solution. Then it goes to control room. So this process should happen in real time. So your model which you are developing, for which you are writing code should work in this scenario when it comes to real life. So this is what we mean by deployment, and this is where your model will be tested in real life. So this is one of the crucial steps. Then you need to evaluate, you need to perform checks that whether your model is performing well, is it following the safety regulations, it is what false negative, what is false positive, and it is not misclassifying something or it's not performing wrong. And this needs to be 24/7 surveillance. So if there is some bug or error that occurred, you can't wait for 10 to 15 minutes, oh I'll come back and then I'll debug. No, this all needs to be automated. This has to be self-driven because this needs to work 24/7. So this all aspects need to cover in machine learning in production. So for that, these are the major elements that you need to take care of. Now, we'll go through this each part in detail and then we will discuss them in a separate video lectures as well because these topics are equally important and they need to be understood because technical skills are not just enough. You need to have the knowledge of this theoretical concept as well. So now let's move to the each part of these major elements and let's understand them in brief. Now let's look at the pie chart where author Ben Wilson in the book Machine Learning Engineering in Action have shown us that why most of the ML project fails and what is the reason behind them. Let's see what kind of reason contributes for the most of the percentage of the failure of the ML project. Let's go with the planning. As you can see, 30% projects have been reported that failed due to planning. When you have a vague idea about the project, then how you can expect a concrete outcome? Vague ideas will lead to vague outcome. So you should definitely ask stakeholders about clear requirements and plan your project accordingly. Next is scoping and research, which contributes 25%. This is a huge number. When you have a proper planning, but you don't do enough research that what algorithm I have to use, what kind of existing work is available, and what kind of database I'll be getting. And if you get a database in CSV file, but your algorithm doesn't support to work in that database, and you started to work on that algorithm, then that will lead to failure of the project. So you need to think about scope and the research as well. Next is technology, which contributes 15% to the failure of the projects reported all over. So imagine you have a startup company where you are done a lot of planning for the project that is given by government to you. You have a lot of research, algorithm is designed, you ask for the database, you thoroughly went through it, and when it comes that you have to run that algorithm on that database, you don't have enough GPUs. At that point, technology will be the reason for the failure of your project. When you don't have computing resources enough for your project, that time will claim that lack of technology has led to failure of the project. Next is fragility. That accounts for 15% of the failure of the project. Fragility. What do you mean by fragility? Fragility means where your code doesn't run properly for a few of the test cases, where you try to take all the test cases into consideration, but at some point you fail to think at the overall level, and then if that test case arrive, your project might fail. Imagine nowadays we have different number plates. Earlier in 2010, we used to have different number of plates, and now the government has said that we have to change the number plates accordingly. Imagine if this change was not implemented, then your previous number plates and new number plates may have different way. And if you want to recognize the vehicle, and if you didn't consider this case, if you don't have the knowledge of this, then definitely your project might fail. Now, since we are getting consistent into that, that may be reason this point is not needed now. But if this distinction was not made, then we might have to think about it. Next is cost. Surprisingly, this accounts 10%. I think many of you have thought that cost might have contributed 50% or somewhere, because always we think that we may not have enough fund, and that's the reason the project didn't go ahead. That's the reason project didn't work out. No, cost is not the always main reason. Their planning, scoping contributes a lot. That's why we want to focus that these aspects are equally important, not only technical knowledge. And next is hubris. That is, you have underestimated the project. You are a little overconfident that, oh, I can manage this project and this will happen. This accounts very less, but still is equally important to think that you never underestimate a project, whether it is easy or hard. Now, ML projects are often harder, unlike typical software projects. They usually start with vague goal, and they have to rely on evolving tools. Every day when I open LinkedIn nowadays, I see there's a new AI tool. People have developed different AI agents. So every day I woke up, I think there's something new algorithm. Till now I was learning LLMs, then suddenly I think I have to learn AI agents. So this change happens very fast, and to match this pace is difficult. This is not what typical software projects go with. So for ML projects, we need to think that how we are going to match with the industry trend. Just as software engineers decades ago refined their process from large waterfall model to the agile model. I would like to explain you a little bit if you don't know about waterfall or agile model. Waterfall model, you can imagine it as top to bottom model, where when you complete the first step, then you go to next step. It's a rigid model. You have the requirements, and once requirements are written down, you go to design. But from design, you can't go back to requirement if change is asked by the stakeholder. So this is waterfall model. And whereas now we prefer agile models, that is an iterative model. So we review, we test, we design, then we redesign, we think about requirements again, and then we go back, and then we again go through the cycle, and then we launch a model. So for the agile model, we take requirements, then we think, we design, we develop, then we test, we rethink about our requirements. If we need any changes, then we incorporate them. Then we again design it, again develop it. And with the number of iterations, when we get up to final stage, at that point we launch. So this is flexible approach rather than the rigid waterfall approach. Now for MLE, we also need this new set of practices and tools that will optimize the software development for the data scientist. And for that, we'll be discussing various aspects that how this can be improved. Now, let us look at the core tenets of machine learning engineering. In the previous part of the video, we have observed there are major elements in machine learning in production that are very important that one must understand, from planning to evaluation. Let us look at them briefly in this lecture. Let's start with planning. Nothing is more demoralizing than building an ML solution that solves the wrong problem. Imagine if you are given a problem and you assume it wrong. You've developed the best solution, invested time, invested resources. But at the end of the day, it seems that the problem was not the problem which you assume. or what was explained to you, you understand it vaguely or was explained vaguely. So it will be the loss of time and resources. In the beginning stage of the project itself, you are not clear with the idea. Then how will the project will finish? Now imagine this. You are a data scientist in a team and you are given the target, and your target is to increase the email openings from the marketing team. So if any pop-up comes to a person, so if that is clicked by the person, then it's a hit. And if it's not clicked or it's missed, then you won't consider it as successful. So you want to increase that people click on the email sent by the marketing team. So there should be more pop-ups. So the team member from the product team comes to say that we want you to develop some algorithm or recommend some good practices so that our emails get more views. Imagine this. Can you build a model that improves user engagement? Sure. But what does improve actually mean? If I was at this position, I would have definitely questioned that what they just want. If they want more user engagement in email, and how they expect me to improve it. So what we observe from here is there is no clear goal. There is no data given. There are no details. They are not giving me correct goal. They are not telling me that what kind of emails do they generally send. There are no details that at what time they send the emails and what is their main aim for sending that email and who is the target audience. These all questions will come into mind as a data scientist team member. So this we call as a vague expectation. Now, if I am given this vague expectations and I have to think of developing a product still, then I would start thinking. And if you were at my position, I think you would probably think in such direction. Should I build a smart subject line generator using NLP so that people click on that email if the subject is very interesting? Or should I recommend products based on user behavior? I should track other sites that what user generally search, and then I should recommend the products through email so that they'll click on the email. Or should I personalize the email content? Or I should send the email to a specific person according to his specific needs and his past history. This is all our very, very cool ideas. Seems like a very exciting project, right? But this may not be the case because here's the twist. None of is what actually needed. All they really want is tell us the best time to send emails so people are most likely to open them. That's it. There is no need of using NLP, AI, recommender system, and whatever I have thought of or you have thought of. But they just want best time to send email. So the moral of the story here is talk before you build. That's why we emphasize that your communication skills are equally important as your technical skills. So always don't hesitate to ask correct and important question if you want to develop product and make it successful. So talk before you build. Without asking right questions early on your risk building a super complex system that no one asked. That is worst. Why is it worse? You'll waste months, you'll lose money, and you will probably kill the project. So at this stage, what you should do? Let us know in comments below, like what would be your first question if someone comes with the problem. So let's see from my end as well. So the first question that I would ask will be, what's the real problem? Like regarding to email, I'll ask them that what do you want? You want user engagement, or you want that it should not be classified as spam, something like that. Then I'll ask, how is it done today? Like what algorithm, what methods, what strategies are you using currently? Then I'll ask, how will my prediction be used? Then if I am planning to use recommender system, I'll tell them I'm planning to use this, but then How will you implement or incorporate this into your current pipeline? Then, next would be, what would success look like? This is what we mean in the previous example, that they want to send at appropriate time. So for them, receiving at the perfect time with respect to that person's country zone is the success. For me, I assumed it differently. So this is what we should improve. So this is like we should do first when someone brings us a problem statement. And this is very important because if a start of a project is not good, then you will probably fail in the future. So ML success isn't about just model. It's about understanding people and problems first. A little planning can save a lot of pain and maybe even your job. Let's start with scoping and research now. If you switch your approach halfway through development, you will face hard conversation with business to explain the project delays that are due to you not doing your homework. I think now we understand why in our school time the teacher used to force us that do homework on time. Because if now in company, if you don't do proper homework, here homework doesn't mean to write something in copy. Rather, it means to have a full knowledge of what you are doing, to have a clear idea. And if you don't have it, you'll deviate from it sometime. And then it will lead to the failure of the project. And you won't able to answer the business stakeholders the reason behind this. Because it was your mistake not having clarity. So when business leader ask about the ML project, they just care about two things. Will this solve my problem? And how long will it take? But answering this isn't always straightforward, especially when different types of data science teams take very different approaches. Now let's take example of team A, which has fast but shallow approach. What they do is they search on internet for the ideas and examples of how to solve the problem. This is the first mistake which we are doing. That is, the only problem here is the length of research. A day is not sufficient. So let's go through the approach which the team A is going. What does team A does is they search for cat versus dogs classification blogs. Then they see there's a lot of material available. Then they click on the article. Then they go through the article. They read about TensorFlow. They see how it is implemented. They see the length of data set, then how the model is compiled. Then they say, okay, so they have used CNN, they have got 97% accuracy on training set, and I'll implement it and I'll test on validation data, and soon I'll release the project. Then they see for the Kaggle notebook on cat versus dog. Then they see this code already written, which has 25,000 images, and the validation accuracy is 98.68, which is very good. It's almost equal to 100. No, it's near to 100, but they think it's 98.68 is very good accuracy. Then they tell the business that their model is ready, and they found one algorithm, in our case which is 16. But like if some team is doing on fraud detection, they say XGBoost the same day. Again, the inadequate research. Then they said it should take about 2 weeks to build. This is underestimating the project. And result of this is when it is implemented using a real data set, then you get false positive and false negative. Model is atrocious, model is useless, is the business response. What went wrong? The research was shallow, or the only day spent browsing beginner content. They underestimated the complexity of the project, and their rushed approach led to the terrible false positive and false negative rates. Then the outcome. The model then solved the problem. Time and efforts were wasted. Let's take a team B approach, that is deep but risky approach. What they do is they search IEEE archive and journals, and then they take the highly cited paper. Let's try to do it. Let's open Google Scholar. Let's search for cats versus dogs classification. I get a lot of papers over here. I'll try to search in machine learning. Then I'll try for the recent one, the cutting edge. Then I see, oh, this is cited by 4, this is cited by 2, this is cited by 6. But I want the recent ones. Oh, so I think this has the information about the cat versus dog problem and it is cited by 57. I'll go with this and I'll suggest that I'll implement this. When I read the paper, I probably won't get the code from scratch. So I'll have to develop the code because I don't have the package there. So it's again extremely risky as it involves building and knowing not only the ML solution but an algorithm as well. Then with the right team, the solution could have been fantastic, but in this case it is not because we don't have that much budget and we don't have that much computational resources. That was the business response. What went wrong? So too much time on theory and research, which didn't lead to the feasibility of the product, and no existing package, then you have to develop something from scratch. Despite it being highly cited, you could not develop and your project was incomplete. It led to the failure. So what was the outcome here? The idea was too costly and risky for business need, so it was never implemented. What will be the middle path? The balanced approach. Too fast is under researched and too slow is over engineered. What will the best practice? Blend the academic practices with practical constraint. This means do a time-bounded thoughtful research and then test the feasibility and then adjust it based upon the context. So this is how you should carry out the scoping and the research part. Now, let us look at the experimentation, which is the third important part of machine learning in production. Testing approaches is a Goldilocks activity. If you don't test enough options, you are probably not finding the best solution. While testing too many things wastes precious time, find a middle ground. In the experimentation phase, the largest cause of the project failures are two major causes. First is experimentation take too long. If you want to pass all test cases, you try to write code such that it covers all your test cases. And in passing that all test cases, you end up wasting a lot of time. Not wasting, you spend a lot of time in that. But if the project has a time deadline and if you just keep experimenting, then time is wasted. But at the same time, if you don't want to cover all test cases, then your prototype will be underdeveloped. And if it's underdeveloped in the real life scenario, it won't work. So again, you'll have to find a middle ground. So let's explore how we can reach to middle ground. Let's see the case of two teams where they have given the classification task and how the both teams take different approach and reach to the conclusion. And let's see how we can find middle way out of it. So let's say team A has a rushed and inadequate experimentation. They find a blog on how to use pre-trained convolutional neural network to classify dogs and cats. So let's see, cat versus dogs classification, medium blog or something like that, any article. So I get an article, oh, cat versus dog. So I just go about that. There are almost 25,000 images in the dataset. Oh, seems like a good number of images. I can use this dataset. Then about the model and the code. Then I see they get a low loss value and they have a good accuracy. And model prediction is good. Cat is predicted as cat and dog is predicted as dog. This is what I want in the classification task. And then I inform my team that yes, the model is ready. I show the demo and we see that cat was categorized as cat and dog was categorized as dog. And yes, my model is good to go. So here, remember, we are doing cherry pick sample training. We are not training it on real life scenario or real life data. The shortcuts have been performed at every stage in this process. When model is trained on full data set, result indicates the very poor performance. For example, you can see this adversarial example where cat images has been added with 0.001 adversarial perturbation. It predicts as dog, which is wrong. So this again is an inadequate way of testing my model. So I need to improve that. I need to handle these cases as well. And because of this, I'll have to rework again from scratch or I'll have to drop the project. Then my time and my efforts are wasted here. So either result cause the business to lose confidence in team or I'll have to rework again. What was the outcome? Outcome was you required either complete work to be done again or you just throw the project. This is not what we want. We want a proper project. But let's see if we try to do it very in a proper manner and in very exhaustive way. Does it lead to a good experimentation? Let's see that as well. Team B is overly ambitious and they have an exhaustive experimentation. They think this topic is complex and they spend 2 weeks researching on options. Like they just open a Google Scholar. Then they search for the classification task, classification methods in machine learning. They saw a lot of machine learning techniques for classification. Then they explored about CNN for classification. CNN for classification. Then they got classification of image using convolutional neural network. Then they started reading such papers. They tried to do a literature survey. Then they tried to find what other models can be implementing by doing this exhaustive literature survey, not with respect to CNN, but with other models as well. They got 3 approaches. First, increase the convolutional and pooling layers and then get a better result. Use a transfer learning and then retain the entire corpus, but you get a good result in this scenario as well. Or use a semi-supervised GANs and generative adversarial networks. So they get these 3 approach. You can see text classification can be done using CNN. So you can use CNN for text classification. At the same time, text classification can be done using BERT as well, where you can use transfer learning to build a model and classify the tweets or the news into fake or real. Then you can even generate the fake faces and then classify what are the fake images and what are the real images using generative adversarial network. With this lot of approach, I am literally trying to get best approach out of this all, but in this I am over developing the things. I am experimenting a lot, and in this analyze and paralyze situation, I am taking a lot of resources and I am taking a lot of time. Because of that, my computation is getting exhausted, and because of that, project is cancelled because that is taking a lot of cost. Because I have to, if I am experimenting with this different architecture, this different complex model, then it's tough. So this is really happening at many places now. You might think you have used a very complex model. At that time you think something innovative, but doing that you waste much of time. You waste much of the computation resource. But at the end, you'll have to think that you have to use such algorithm that give you good result within the time as well. So always make sure that you think in all other aspects. So that's what is very important in machine learning. You need not to just have a technical knowledge. You also have to think around it, that is it feasible, is it scalable. So as you can see, the project was cancelled due to uncontrolled experimentation that exhausted the computational budget without delivering a clear outcome. Overdeveloped prototypes made it difficult to discard any single approach, leading to analyze and paralyze. Despite promising research, the inability to prioritize and make timely decisions caused stakeholders to lose confidence and pull the plug. And for this, what will be the final approach? Final approach will be again finding the middle ground where you don't waste much time into research but you have enough research done. And then you experiment it and keep iterating. You see, okay, this test cases are getting passed. I think we should go ahead. And in the next iteration, you try to think, are the test cases left? But you didn't stop at one point. You try to iterate the process of development and then you experiment at each stage and eventually you will lead to a good project. Now, let us look at the development. As we have seen earlier, writing a testable and executable code is very necessary. For any developer to write a clean code is very important for making any project successful. Let's take an example of Ravi and Priya. They have one Jupyter notebook and Ravi wants to change the age and Priya wants to deal with the region and want to change the features and she want to add the feature region and language with encoding. Both of them spend a lot of time scrolling and making edits and that changes clash and causing error and confusion. They find hard to collaborate on one single notebook and implement their ideas. This is probably a bad approach because most of the project progress slows down due to frequent merge conflicts and bugs. Time is wasted in basic integration issues. Instead of improving the model, the team loses the confidence in the workflow and struggles to collaborate effectively. What will be the better workflow? Let's take our favorite cat versus dog example and understand a simple approach. Imagine I have a team of 2 and I have this single notebook. Now I am thinking that VGC 16 can be replaced with the ResNet 50 and then I can increase the accuracy to 99, which is 98 for now. But at the same time, my teammates suggest that we should increase dropout, which he thinks will increase the accuracy. I don't know which approach will work, but I am saying no, change this to ResNet. He's saying no, keep it as it is, change it to dropout value. This will cause clash between us and we won't be able to collaborate. And then we'll waste our time and our workflow will be disturbed. Then what will be the ideal way? Using GitHub. Probably everyone of you have heard of GitHub. And if not, GitHub is a web-based platform where you can store your code and collaborate effectively. So how it can be done? I uploaded my one notebook on GitHub in .ipynb file. I got this notebook uploaded. After uploading this notebook, I'll share this repository link with my teammate. This will be our initial code. If I want to change or experiment something, I'll download this file on my local setup. We'll try to do experiment whatever the thing is. He will also do at his end on the local setup. And which one will be the best, we can update this file with this. Else, there is another option. I can create the branch of this main repository and I can experiment it and I can upload that this is my new notebook where I have implemented these changes and I got this results. I can have branch for this main repository and we can merge it if that accuracy is better than the actual one. This way we can collaborate easily, we don't have to disturb the workflow and we get a good results and we have a confidence that we can work well. So this is how you should try to optimize the way you work. Like using GitHub as a tool here will help you for developing the code more effectively. So this is how you can integrate GitHub into your daily practices. And then you work independently without stepping on each other's changes. Their tests pass smoothly and merging to the main branch is a seamless integration after testing. So outcome of this was changes were merged quickly and safely. Deployment becomes faster and more reliable. The team saves time, avoid reworks, building the trust in the process. Deployment. Now let's look at deployment. Deployment is something like you don't know how many guests will show up at your dining table for your party. It's like not planning a project around a development strategy. It's like having a dinner party without knowing how many guests are showing up. You'll be either wasting money or you'll ruin the experience. One of the most bigger challenge that a newcomers new teams face regarding the effective deployment strategy. If you have high infrastructure and you don't have high quality predictions, then your cost will go down and if you will waste money. If you have a high quality prediction, but if you don't have good infrastructure, at that point, this will be again problematic. Imagine me being a seller of clothes and I run my small shop. I have given a company to sell my clothes through a website. I can't have a daily check on it, so I give them some stock and I ask them weekly sales. And if that's performing well, I just send them another carton of clothes, and I ask them, okay, please let me know what are my next week's sales as well by the end of this. This is what simply is like batch wise predictions, or you can simply say that I am not demanding real time prediction. So fast food companies DS team, for example, had used a simple batch based ML system for inventory needs at a regional level. But now the new opportunity emerged. The leadership grew more confident in team. Now they want real-time pre-store inventory forecasting. In my case, if we deviate from this and relate it to the my customer sales, and now I can see my sales are very good. And now I want to forecast as well. I want that company to tell me that what sale they're expecting next week. I want this forecasting as well now. I just want the record of what sale was done this week. That time I'll have to integrate the real-time predictions into the system. Now, this is tough case. It's tough because of various reasons. You have to code it, you have technical stuff as well. But the problem is when you emerge with this real-time idea, you will have to hire some developers that bring you the REST API. And then with the help of those engineers, you will handle the frequent prediction updates and the new request volume will be managed. However, within a week of deployment, a new setup with a complex architecture and ARIMA model will be proved too costly. ARIMA model, you can just think it as a auto-recursive model which use time series data to predict the future. So solving a novel problem with a clever algorithm is tempting, but overlooking cost can sink the project. While we focus on innovation, decision makers focus on return of invest. So it's always better that it's wiser that we assess the feasibility in the planning phase itself, so that in latter part of the project when we invest, we don't have to shut it. So it's better that we measure the business impact first and then build with the purpose. So these points need to be kept in mind when you think about deployment. We'll go in detail of deployment in the further part of lecture series as well. For brief explanation, please keep this all in mind. So next you'll have is evaluation. Evaluation is the last part of this core tenant elements of machine learning in production. If you can't justify your product being in production, don't expect it to remain them for very long. Even if model performs well in production, but if its business impact is not seen, then your product won't last long. You'll have to show the business stakeholders that my product is actually doing well. It is having an impact. So you'll have to deal with definite statistical methods to estimate the gains. To explain it simple language, let's consider a simple case of the vehicle detection system, government surveillance, which we understood in the first part of the video. I wanted to check if I am detecting the vehicles correctly or not. So at that point, what will I try to do is I'll contact the government agency or the point of contact person. I'll ask that, do you ever face any problem If he says no, no problem was faced, then I'll be happy. But there's another story of this. They might think this is a very normal task. There's no innovative thing or no impact that has been happened. If someone is trying to break rules, if someone is trying to overtake the car, if the speed limit is going above, if that has been constantly monitored and informed to control room at some point, they'll think the impact is real. They'll see, okay, so I'm able to manage the traffic. It's not just detecting the number plate, or it's not just scanning. So this is how we should show that our product is having impact as well. So for that, there are various statistical methods, and popularly we use A/B testing, and A/B testing will be going through it in detail in the lecture series. But for now, just consider that A/B testing is something. I have a variant A, I have a variant B, I have an audience which I divide into two groups with a random percentage. And for one product, I have two variants. And I ask them to judge these variants on basis of KPIs, that is key performance indicators. And then I analyze which variant was good. Make sure that my product is having impact and it is not biased as well. So this is one of the very popular method used to check the impact. Since we have observed the major elements in machine learning engineering, now let's look at the goals of machine learning engineering. The core goal of data scientists is to solve a complex problem using statistics, algorithms, and predictive modeling. The aim is not to build fancy looking systems that won't have a good real life impact. Rather, we have to build such system which is scalable, profitable, and is easy to use. Data scientists exist to tackle the tasks that are too complex, repetitive, or error prone for human. Data scientists have access to a vast array of tools, which sometimes can lead to overemphasis on technical complexity. That's what we are emphasizing from the starting of the lecture, that you should have technical aspect as well along with the communication skills. So both will go hand in hand if you want to succeed in this field. Without a clear process guide, it's easy to lose focus on solving real world problems. Now, we are in the last part of lecture. Let's summarize what we have learned till now with the help of flowchart. Don't get overwhelmed by seeing this big figure. We'll go through it phase wise and we'll try to understand it in this simpler form. So, in the planning phase, as we have seen, you have to gather requirements. You have to ask the business developer what is exactly the problem statements. Then you have to take a subject matter experts interviews and you have to define a problem. Then you have to perform a data validation and exploratory data analysis. Exploratory data analysis may involve data distribution to find the missing data, to find some patterns, to ensure data quality, to see what are the data types, and to see if there is outlier in data. Or you will also have to build a project team and define research goal, because it's better to start properly than failing at the end. Next will be research and scoping phase. You'll have to explore what are the existing work done and what were the strategies used to solve that problem previously. You'll have to read books, blogs, and paper. You can use Google Scholar for that. Even you can use paper with codes. And there are a lot of tools that can be used for such purpose. Then you will explore about the packages, frameworks, and platforms available for that problem statement. And then you will decide and define which approach you have to test. Is experimentation phase. These both phases are cross-functional. So you'll have to search something here as well, and you'll have to work here as well. You'll have to search for the different business metrics and you'll have to read different articles as well. Next is experimentation phase. You'll have a proof of concept bake-off, and you'll have a complexity and cost evaluation. You'll experiment and you will evaluate what will be the estimated cost of the project, and then you will have a business unit feedback. Then you will select a project approach and define engineering objectives. So for proof of concept, you can think of like you create the scope, then you outline the success criteria, then you document learnings, and then plan next steps. Next will be our development phase. This was what will go or what will not go in the project. So this is experimentation phase. But next is development phase. In development phase, we'll build phased MVP approach, that is minimal viable product. Then we'll test the validation of the simplest approach. Then we'll get the feedback from the subject matter experts. Then we'll have a production hardening test like MLOps tooling. This will be done in development phase. So you'll write the code which is testable and executable. Then you'll go to development phase where you'll have the final subjective quality assessment. You will do A/B testing. You will have the two groups where you will show them variation A and variation B. You will randomly divide the groups into different percentage and get the feedback on the variance. Next will be model measurement, tracking and drift monitoring. This all is in project commit part. So when you are committing the final project, this all will help you. Next is the evaluation phase where you will retraining, that is drift mitigation. Then you will prove the value of your project, that it is impactful and it is helping business to grow. Then you will take feedback from the business expert on the performance of your tool. Then you will check for the cost, SLA and uses monitoring. This will all be the evaluation phase. So the evaluation phase, deployment and development will come in the project commit. But at some point, imagine at evaluation phase, you see the performance is low. At that time, what will you do? You will again have to go to the experimentation phase and you'll have to experiment something to improve the performance. So this is kind of cycle that will go on. This was all about the major core tenets in machine learning engineering. In the next lecture, we'll be studying about data science could use some engineering. So the content that will be covered in the next lecture will be what is the difference between data scientist and machine learning engineer, how we can reduce risk in a project in a simple manner, what are the agile fundamentals and how can we apply it to ML project work. Then we will illustrate the difference between DevOps and MLOps. So stay tuned for the next lecture. Hope you enjoyed the video and learned something new. If you have any feedback, please let us know in the comments. If you have any question, please input that. If you have any questions, please let us know. Stay tuned for the next lecture. Okay, bye. Have a good day.